Welcome to another video by Adeptis Academy. Imagine you want to build a bookshelf. You have a vision in your mind of what it should look like. Maybe it has 3 shelves, or maybe it's tall and narrow to fit in a corner. But before you even pick up a single piece of wood, you sit down and sketch out your idea. You draw the shelves, the sides, and the back, making sure every measurement is just right. This drawing becomes your guide, your plan for turning a pile of wood into a sturdy, beautiful bookshelf. Now imagine if you skipped this step. If you just grabbed some wood and started hammering pieces together without a plan, you'd probably end up with something wobbly, uneven, or maybe not even recognizable as a bookshelf at all. The blueprint is what keeps you on track, helping you avoid mistakes and making sure everything fits together perfectly. In the world of construction, blueprints are essential. They're detailed drawings that show exactly how to build something, step by step. Builders and architects rely on them to make sure every wall, window, and door ends up in the right place. Without blueprints, even the most skilled builder would struggle to create something reliable. Circuit diagrams are like blueprints, but for electronics. Instead of showing shelves and boards, they show wires, batteries, switches, and other electronic parts. These diagrams are the foundation for every electronic device you use, from your phone to your computer to your TV. They show us how electronic components connect, creating a working circuit. Each line represents a wire, and each symbol stands for a different part, like a resistor, a light bulb, or a battery. By following the diagram, you can build a circuit that works exactly as intended. These diagrams use symbols to represent different components, making them easier to understand. Instead of drawing a tiny picture of a battery or a switch, we use simple shapes and lines. This universal language lets engineers and hobbyists all over the world read and build circuits, even if they speak different languages. Just like a blueprint helps you build a bookshelf, a circuit diagram helps you build anything electronic. Whether you're creating a simple flashlight or a complex computer, it all starts with a plan, a blueprint for your ideas. With a good circuit diagram, you can turn your imagination into real working technology. Circuit diagrams use a universal language of symbols. These diagrams are the blueprints of the electronics world, allowing engineers, hobbyists, and students to communicate complex ideas with just a few simple marks on paper. No matter where you are in the world, these symbols mean the same thing, making it possible for people from different backgrounds and languages to collaborate on designing, building, and troubleshooting electronic devices. This visual language is essential for anyone who wants to understand how electronic circuits work, and it forms the foundation for all modern electronics. Each symbol represents a specific electronic component, acting as a kind of shorthand that makes complex circuits easier to read and understand. Instead of drawing a detailed picture of every part, we use these symbols to quickly convey what's happening in a circuit. This not only saves time, but also reduces confusion, especially when dealing with intricate designs that might contain dozens or even hundreds of components. By learning these symbols, you gain the ability to interpret and create your own circuit diagrams, opening up a world of possibilities in electronics. Let's start with some basics. One of the most common components you'll see is the resistor. In circuit diagrams, a resistor is shown as a zigzag line. This simple shape represents a device that resists the flow of electrical current, helping to control how much electricity moves through a particular part of the circuit. Resistors are used to protect sensitive components, adjust signal levels, and divide voltages. By recognizing the zigzag symbol, you can immediately identify where the circuit is designed to limit or control the flow of electricity. Next, let's look at the capacitor. In schematics, a capacitor is represented by 2 parallel lines, sometimes with one line curved. This symbol stands for a component that stores and releases electrical energy, a bit like a tiny rechargeable battery. Capacitors are used in a wide range of applications, from smoothing out power supplies to filtering signals and timing circuits. When you see this symbol, you know the circuit is designed to temporarily hold and then release energy, which can be crucial for the operation of many electronic devices. Another important symbol is the switch. In diagrams, a switch is shown as a line with a break and a dotted line, indicating that it can open or close the circuit. When the switch is closed, electricity can flow. When it's open, the flow stops. Switches are everywhere in electronics, from the power button on your phone to the light switch in your room. Recognizing this symbol helps you understand how and where you can control the flow of electricity in a circuit. The battery is another fundamental component, and its symbol is 2 parallel lines, one longer than the other. The longer line represents the positive terminal, and the shorter one is the negative terminal. Batteries provide the electrical power that drives the circuit, and their symbol is a universal sign of energy in electronics. Whether you're looking at a simple flashlight or a complex robot, the battery symbol tells you where the power comes from and how it's supplied to the rest of the circuit. Wires are just simple lines that connect the different components. These lines show how electricity travels from one part of the circuit to another, forming the pathways that link everything together. Sometimes you'll see dots where lines cross, indicating a connection, or you might see lines that cross without a dot, meaning they don't connect. Understanding how wires are represented helps you follow the flow of electricity and see how all the components interact. Think of these symbols as the words in an electrical sentence. Just as letters form words and words form sentences, these symbols come together to create a complete story about how a circuit works. The arrangement and connection of symbols tell you what the circuit is designed to do, whether it's amplifying a signal, powering a motor, or lighting up an LED. By learning to read this visual language, you gain the ability to understand and design your own electronic creations. By understanding them, you can read what the circuit does. This skill is like unlocking a secret code that reveals the inner workings of everything from simple gadgets to advanced technology. As you become more familiar with these symbols and how they fit together, you'll be able to troubleshoot problems, modify existing designs, and even invent new devices. Mastering the visual language of circuit diagrams is the first step on your journey to becoming fluent in the world of electronics. Just like ingredients in a recipe, electronic components have units of measurement. Ohms, or omega, measure resistance, which is how much a resistor restricts current flow. Farads measure capacitance, or how much charge a capacitor can store. Volts measure voltage, which is the electrical potential difference. And amps measure current, the flow of electrical charge. These units help us understand the strength and capacity of each component in a circuit. The lines in a circuit diagram represent wires. These wires act as pathways for the electrical current to flow. Current always flows from a point of higher voltage to a point of lower voltage. Think of it like water flowing downhill. The steeper the hill, or the higher the voltage difference, the faster the water flows, which means a higher current. Let's take a closer look at one of the most fundamental building blocks of electronics, the simple circuit. Imagine you have a battery, a switch, and a light bulb. These three components, when connected by wires, can create a complete path for electricity to flow. This is called a circuit. The battery acts as the power source, providing the energy needed to move electric charges through the wires. The switch is like a gatekeeper. It can open or close the path, controlling whether electricity can flow or not. The wires themselves are the roads that connect everything together, allowing the electric current to travel from the battery, through the switch, and finally to the light bulb. When the switch is open, the circuit is broken. No electricity can flow and the light bulb stays dark. But when you press the switch and close the circuit, something amazing happens. The path is complete, and the electric current begins to flow from the battery, through the wires, and into the light bulb. Inside the bulb, the current passes through a thin wire called a filament. As the current moves through this filament, it heats up and starts to glow, producing light. This is the basic principle behind how many of our everyday devices work, from flashlights to lamps and even some toys. By simply opening or closing the switch, you control whether the light bulb is on or off. This simple circuit is a perfect example of how electrical components work together to create something useful. It also shows us how important each part is. Without the battery, there's no power. Without the wires, there's no path. Without the switch, there's no control. And without the bulb, there's no light. Understanding this basic setup is the first step toward exploring more complex circuits and discovering the fascinating world of electronics. There are two main ways to connect components. In a series connection, components are connected one after the other, kind of like links in a chain. The same current flows through each component. In a parallel connection, components are connected on separate branches, so the current divides and flows through each branch. Understanding these configurations is, honestly, just essential for designing and analyzing more complex circuits. Circuit diagrams are everywhere in the world of electronics. They're used to design and build everything from simple toys to, complex smartphones. Engineers rely on them to troubleshoot problems, test new designs, and communicate their ideas. So next time you use your phone or watch TV, just remember the intricate network of circuits working behind the scenes, all mapped out in a circuit diagram. Learning to read circuit diagrams is, in many ways, like learning a new language. It really opens up a world of understanding about how electronics work. This knowledge empowers you to repair electronics by identifying faulty components and understanding how to fix them. Build your own gadgets by designing and creating your own electronic projects. And, honestly, better understand technology by appreciating the complexity and ingenuity behind everyday devices. This is just the beginning of your journey into the fascinating world of electronics. There are countless resources available online and in libraries to help you deepen your understanding. So keep exploring, keep learning, and never stop asking questions.